Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the part 1 and part 2 of the circle videos where we have seen many concepts and some very important theorems like inscribed angle theorem, alternate segment theorem, theorem on tangents and secants, length of direct and transverse common tangents, and so on. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In this video, we are going to do some problems based on the concepts that we have seen in part 1 and part 2 of the circle videos. But before seeing this video, I would suggest you all to go through the earlier videos of geometry, as many concepts of the earlier videos are also being used in solving the problems in this video. Also, before seeing the solution of every question, I would request you all to attempt those questions from your end first and then to check the solution. So let us start with this video. Let us begin with this question. Here we have been given a figure where PQ is a diameter and this diameter PQ is extended to a point R. There is a tangent RS which is drawn, and this tangent RS is touching the circle at point T. Also, the measure of the angle QPT, that is this angle, is given to be 36 degrees. We need to find the following angles, that is angle TOQ, angle PTO, angle TQP, angle QTR, angle QRS, and angle PTS. To find these angles, I have joined the points O and T to form the line OT and join the points T and Q to form the line TQ. Now, if we consider this arc formed by the points T and Q, in that case, this arc is forming an angle of 36 degree at point P, that is at the circumference. And from inscribed angle theorem, we know that the angle formed by any arc at the center would be twice the angle at the circumference. So if this angle is 36 degree, then this angle would be twice of 36 degree, that is 72 degrees. So angle TOQ is 72 degrees. Now to find angle PTO, let us use the exterior angle theorem, which states that any exterior angle of a triangle is equal to the sum of the two remote interior angles. So if we consider the triangle PTO, in that case, this angle would be the exterior angle. So this angle would be equal to the sum of this angle plus this angle. So we can write angle TOQ equal to angle TPO plus angle PTO. Now angle TOQ is 72 degrees and angle TPO is 36 degrees. So from this we can write angle PTO to be 36 degrees. So measure of angle PTO is 36 degrees. Now, since this angle is 72 degrees, so we can say that this angle would be 180 minus 72 degree, that is 108 degree, as this angle would be a straight angle, that is 180 degree. Now 108 degree is the angle formed by the arc PT at the center. So the angle formed by the arc PT at the circumference would be half of this angle. And the arc PT forms this angle at the circumference. So this angle would be half of 108 degree, that is 54 degrees, which we are able to find simply by using the inscribed angle theorem. So angle TQP is 54 degrees. Now, in the second part of the circles videos, we have seen one very important theorem, which is alternate segment theorem, which states that an angle between a chord and a tangent is equal to the angle made by the chord in the alternate segment. So here we can see TQ is a chord, RS is a tangent, and this is the angle formed by this chord and the tangent. So this angle would be equal to the angle formed by the chord in the alternate segment. And the angle formed by this chord in the alternate segment is 36 degrees. So this angle will also be 36 degrees, which we are able to find simply by using the alternate segment theorem. So angle QTR is 36 degrees. Now, to find the angle QRS and angle PTS, we can again use the exterior angle theorem. That is, any exterior angle of a triangle is equal to the sum of two remote interior angles. So, if we consider the triangle TQR, in that case, this is the exterior angle. So, this angle would be equal to this angle plus this angle. So, from this, we can write angle QRS to be 54 minus 36 degree, which is 18 degrees. So angle QRS is 18 degree. In a similar way, if we consider triangle PTR, in that case, this angle would be the exterior angle. So angle PTS would be equal to angle TPQ plus angle TRP. From this, we can write angle TPQ to be 36 degrees and angle TRP to be 18 degrees. So from this, angle PTS would be 54 degrees. So angle PTS would be 54 degrees. Now say if we have been asked to find this angle, then we can find this angle simply by using angle in a semicircle is 90 degree. The line formed by joining the points P and Q represents the diameter of the circle, and T is a point on the circumference of the circle. So this angle would be an angle in a semicircle. So this angle would be 90 degree. So from this, we can say that angle OTQ can be written as 90 minus angle PTU, which is 36 degrees. So from this, angle OTQ would be 54 degrees. So in this way, simply by using some important theorems like inscribed angle theorem and its corollaries, alternate segment theorem, and so on, we can find the measure of such angles. Now let us see this question. So here we have been given a circle where O is the center of the circle. The length of OP is given to be 7.5 centimeter. The length of AB is given to be 5 centimeter, and the length of the radius OT is given to be 4.5 centimeter. We need to find the length of PB. In part 2 of the circle videos, we have seen one very important relation between a tangent and a secant. Here, PT is a tangent to this circle and PAB is a secant to this circle. So we can directly use that relation, which in this case would be PT square would be equal to PA into PB. And this relation is known as tangent secant theorem. So here we can directly use this tangent secant theorem to find the length of PB. In the last video, we have also seen one theorem on tangent, which is any tangent to a circle is perpendicular to the radius of the circle at the point of tangency. Here, PT is a tangent and OT is the radius of the circle. So PT would be perpendicular to this radius OT. So this angle would be 90 degree. Now, if we consider the triangle OPT, in that case, this is a right angle triangle, right angle at T. So we can directly use the Pythagoras theorem here. That is hypotenuse square is equal to perpendicular square plus base square. Here, OP represents the hypotenuse. So this can be written as OP square, which would be 7.5 square to be equal to perpendicular square, that is OT square, which is 4.5 square plus base square, that is PT square. From this, we can find the value of PT square to be 36. Now, to find the length of PB, let us assume the length of PB to be x and the length of AB is given to be 5 centimeter. So the length of PA would be x minus 5 centimeter. Now, if we use the value of PT square to be 36 and the length of PA to be x minus 5 and the length of PB to be x, in that case, from this relation, we can write 36 to be equal to x minus 5 into x. Now, when we simplify this, we'd be getting a quadratic equation, which would be x square minus 5x minus 36 to be equal to 0. And when we solve this quadratic equation, we'd be getting the value of x to be 9. That is, the length of PB is 9 centimeter, which we are able to find simply by using the tangent secant theorem. So in this way, we can directly apply the tangent secant theorem to find such lengths. Now let us see this question. Two circles of radii 6 centimeter and 8 centimeter are such that their centers are 10 centimeter apart. We need to find the length of the common chord of these two circles. To find the length of the common chord of these two circles, I have drawn two circles here with radii 8 centimeter and 6 centimeter. The points A and B represents the centers of these two circles with radii 8 and 6 centimeter respectively. So the length AB represents the length between the centers of these two circles, which is given to be 10 centimeter. So the length AB is 10 centimeter. Let these two circles be intersect at points P and Q. So the length PQ represents the length of the common chord between these two circles. So we need to find the length of PQ here. We know in case of two intersecting circles, the line joining the centers of the two circles will perpendicularly bisect the line joining the points of intersection. So here, the line joining the centers of the two circles AB will bisect perpendicularly the line joining the points of intersection, that is the line PQ. So we can say that these angles are 90 degree and T is the midpoint of the line PQ. So the length PT is equal to the length TQ. Now, if you observe carefully in triangle APB, the length of AP is 8, the length of BP is 6, and the length of AB is 10. And we know 10 square is equal to 8 square plus 6 square. So the lengths 6, 8, and 10 represents a Pythagorean triplet. So that means triangle APB is a right angle triangle, right angle at P. And we know the area of a triangle is given by half into base into height. So for this triangle APB, if we consider the side PB to be the base and the side AP to be the height, in that case, the area can be written as half into PB into AP. Also, if we consider the side AB to be the base and the length PT to be the height, in that case, the area would be half into AB into PT. So both these areas would be equal. Now, if we simply put the values, in that case, this would be half into 6 into 8, which would be equal to half into 10 into PT. So from this, we'd be getting the length of PT to be 4.8 centimeter. Now we know T is the midpoint of PQ. So the length of PQ would be twice of the length of PT. So this would be 2 into 4.8, which would be 9.6 centimeter. So the length of PQ, that is the length of the common chord between these two circles, is 9.6 centimeter. So in this way, we can find the length of the common chord for such kind of circles. Now let us see this question. So here we have been given a figure where ABCD is a cyclic quadrilateral with center O. AB and DC, when extended, they meet at point P. Angle AOC is given to be 120 degree. Angle APC is given to be 40 degree, and we need to find the angle BCD. So angle AOC is given to be 120 degree. Angle APC is given to be 40 degrees, and we need to find angle BCD, that is this angle. To find the angle BCD, let us consider the arc formed by the points A and C, that is this arc. This arc is subtending an angle of 120 degree at the center. So from inscribed angle theorem, we can say that the angle formed by this arc at the circumference would be half of this angle. So the angle formed by the arc AC at point D would be half of 120 degree, that is 60 degree. Simply by using the inscribed angle theorem. Now, for a cyclic quadrilateral, we know that the opposite angles of a cyclic quadrilateral are supplementary. So angle ADC plus angle ABC would be 180 degree. And angle ADC we know is 60 degree. So from this we can say that angle ABC would be 120 degrees. So angle ABC is 120 degree. Now we know that this angle is a straight angle. So this would be 180 degree. So if this is 120, so we can say that this angle has to be 60 degrees. Now if we consider the triangle BCP, in that case, this is the exterior angle. And we know that for any triangle, any exterior angle is equal to the sum of two remote interior angles. So angle BCD would be equal to angle CBP plus angle BPC. Angle CBP is 60 degrees and angle BPC is given to be 40 degrees. So from this we can say that angle BCD would be 100 degrees. So the measure of angle BCD is 100 degrees. So in this way, by using the inscribed angle theorem and using the properties of a cyclic quadrilateral, we can find such angles. Now let us see this question. A cow is tied with a rope of length of 30 meters at one of the corners of a rectangular wall of length 40 meters and breadth 15 meters. This rectangular wall is surrounded by grass everywhere. We need to find what is the maximum area that this cow can graze. Here, I have considered a rectangular wall of length 40 meters and breadth 15 meters. And at one of the corners of this rectangular wall, a cow is tied with a rope of length 30 meters. This rectangular wall is surrounded by grass everywhere, and we need to find what is the maximum area that this cow can graze. Well, if there would have been no rectangular wall, in that case, this cow could have been able to graze the complete area of this circle with this point as the center of the circle and the length of the rope tied to the cow as the radius of the circle. But because of this rectangular wall, the cow won't be able to graze some of the areas. Now, from this point to this point, the cow would be able to graze 75% of the area of the circle, that is 3/4 of the area of the circle. But after reaching this point, the cow won't be able to cover this complete area, rather a portion of this area, as from this point onwards, the cow's rope would be bent with a different radius, which would be the difference of the rope's length and the breadth of the rectangular wall. That is 30 minus 15, which would be 15. So from this point onwards, the cow would be able to graze 25% or 1/4 of the area of a circle whose radius is 15 meters. So this shaded area would be the total area that this cow can graze, which would be 3/4 of the area of a circle whose radius is 30 meters and 1/4 of the area of a circle whose radius is 15 meters, which would be 3/4 into pi into 30 square plus 1/4 into pi into 15 square, as the area of a circle is pi r square, which when we simplify, it would be 2925 pi upon 4. Well, if some of you are wondering how we are getting this area as 3/4 of the area of the circle with radius 30 meters and this area as 1/4 of the area of the circle with radius 15 meters, then you can think in this way. Since this is a rectangular wall, so this angle would be 90 degree. So this remaining angle would be 360 minus 90, that is 270 degree. As this would be a complete angle, and we know that when the central angle is 360 degree, then we get the complete area, which is pi into r square. So when the central angle would be 270 degree, in that case, we'd be getting the area as 270 upon 360 into pi r square, which comes to be 3/4 into pi r square. So that's why the area of this portion is 3/4 of the area of the circle. And here the radius is 30 meters. So that's why the area is 3/4 into pi into 30 square. In a similar way, if this angle is 90 degree, so this angle will also be 90 degree. And again, we know that 360 degree angle represents the complete area, which is pi r square. So 90 degree will represent 90 upon 360 into pi r square, which is 1/4 of the area of the circle. And here the radius is 15 meters. So the area of this portion comes out to be 1/4 into pi into 15 square. So the total area of this green shaded portion is 3/4 into pi into 30 square plus 1/4 into pi into 15 square, which when we simplify comes out to be 2925 pi upon 4. So the maximum area that this cow can graze is 2925 pi upon 4 meters square. So that's it for today's video, in which we have seen some problems based on the concepts that we have seen in part 1 and part 2 of the circle videos. But I would suggest you all to practice some more questions, because the more you practice, the more you learn. In the next video, we are going to start with mensuration, where we will be seeing various 3D figures like cylinders, spheres, cones, and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.